In this last video, we're going to go through the analyzing the data section of this lab. I'm on slide 14 right now, and it's asking me essentially a repeat of what I just did on the previous one. What is the equation that best fits the data? I'm going to go back to my slide 13, and I have that right here. This is, again, my fake data. Potential energy equals 30 times gravity squared. So I'm just going to go ahead and plug that in. I'll say potential energy equals 30. That's my K value. I don't want to just put in K because I actually know what K is here. 30 times gravity squared. And you know what? I think I can do this. Yeah. There we go, gravity squared. And you can go ahead and put in your multiplication there as well. So that would be my equation. I can press share with the class. I'm not going to do that because, again, this is fake data. I want you to have accurate responses in that show up when you do this. So you will find that this is a proportional relationship. We have a name for this. It is called proportional. This should be the shape of the graph that you saw in your data. So there's a lot of things about what this means. We can see that as x doubles, y doubles. So as x doubles, right, from 1 to 2, we see that y goes from 5 to 10. It's doubling. So we call this relationship proportional when we see that straight diagonal line starting at 0 and going just right on up by a level, so proportional. Excuse me. You guys are probably fairly comfortable with seeing this kind of line in your math classes. So we already looked at a horizontal line, and now I want us to compare that to a proportional line. So based off of what we saw with the pendulum swing and what we saw in this one, how do these lines look similar? List two similarities that you notice. And then list 3 differences that you notice. Now, the differences might actually be a little bit easier. I definitely can see some things that look quite different, and we can see these side by side. I want to know that you can identify the kind of relationship that we saw in our data. There we go. So what kind of relationship did we find? And then we're going to do our claim evidence reasoning. We're just going to keep coming back to this. So how does the independent variable, whatever it was that you studied of an object, affect its potential energy? All right. Now, this is actually fairly important. This is a big, hefty sentence frame that I would like for you to use. It's going to give you a really strong scientific argument. What I want you to do is to take this and copy all of this text, Control C, and paste it, Control V, into here. And then everywhere where you see these lines, you're going to be putting in the information that you see here. So after investigating the relationship between your independent variable and the dependent variable, I do want to know that you can identify our dependent variable. I found A, and then go ahead and delete the unnecessary stuff here, relationship. So you're turning this into a sentence. Please don't leave both of these things here. You didn't see both a horizontal and a proportional relationship. You saw just one of those. My evidence is the graph, which shows, describe what the graph looks like and how that shows us how the independent variable affects the dependent variable. This is maybe even more than one sentence here. I want to see what the graph looks like. That's going to be part of your evidence, and what that is telling us about it. The equation of the line is which states that potential energy is equal to. So I'm asking you to give it to me as a math statement, and then I'm asking you to turn that into a word statement. What does this equation mean? Okay, give that to me in words. So for instance, I could say potential energy equals 30g squared, which states that potential energy is equal to 30 times the amount of gravity squared. That's what that would look like, and I'd write that all out. Okay, this makes sense because we know that. And here I want you to show me your understanding of the science behind it. Why do you think that we got this kind of relationship? Show me that you understand how this kind of relationship, like why does it make sense that these things would affect the potential energy at any given point? Okay. So, I want you to grapple with this. I would love if you are in that breakout room to be talking to each other and trying to work that out together. If you're in the main room, I also strongly encourage you to be talking. You might want to check in with the substitute. You might want to check in with other students. So I will let you work through this. This is definitely a challenge here. I'm looking for the full thing. In the last Pendulum Lab, we broke this up into 3 different slides and you had some things that you could select. Now that we've done that as practice, I'm asking you to be producing the whole thing. Go ahead here and mark on a scale of 1 to 4 how well you feel like you did in these 4 different categories. And if this is as far as you get, oh my gosh, that's awesome, right? Congratulations. And we are going to be definitely talking about this next stuff here, but this is putting it all together. So there's actually an equation for how all of these things work together. And you can take a look at this slide and then make your data informed prediction based off of that slide and based off of your previous understanding. If I were in class today and we had gotten to this point, we would be doing all of this as a whole group discussion and then making our prediction afterward. I'm going to leave these 2 slides open for you so that you can give this a try. But if you just get to this point and you've gotten everything else done, you can consider yourself, whew, I'm done, and give a high five and go through and make sure that you really like everything that you've written, and I will be looking at that. So thank you so much. And I am looking forward to looking at your work over spring break.